Based on the problem, we could write the given using a circuit diagram. The 220 square root of 2 times e to the negative t voltage source is in series with the 151 ohm resistor and the 0.021 farad capacitor. The requirements are the function of I with respect to t, I and q when t is equal to 5 seconds. Solution. Using the formula for the sum of the voltages in each component in a series circuit and being reminded that I is equal to the derivative of q with respect to t, we could evaluate the formula with this equation. We multiplied it by dt over 151, resulting to this equation. And we could notice that it is in linear NQ. And identify that its t sub t is equal to 0.315 and its q sub t is equal to 2.060 times e to the negative t. The integrating factor would be v of t equal to e to the integral of p sub t dt, which is e to the integral of 0.315 dt. And the integral of that is 0.315t. The general solution. The formula is q times v of t equal to the integral of q sub t times v of t dt. And we evaluate the formula for the general solution with the v of t, the q sub t, and the v of t again. We integrate the right hand side using u equals negative 0.685t and du equals negative 0.685 dt, resulting to this equation. And we integrate this to this and evaluate u and adding the arbitrary constant c. This results to the equation, and transposing the left hand side e to the 0.315t to the right hand side, the two e's of the first term will minus 2 negative t. And at t equals 0 and q equals 0, we could find the arbitrary constant c. And substituting the c in the equation for q would result to the particular solution. Then, we get the I using the equation, the derivative of q with respect to t. So, the derivative of q, the negative times the negative will be positive 3.007 e to the negative t. And the negative 0.315 times 3.007 is negative 0.947 times e to the negative 0.315t, resulting to the final answer. The function of current with respect to t is equal to 3.007 e to the negative t minus 0.947 e to the negative 0.315 t.